So my name is Brent. I'm actually a material scientist. I started off when I was a kid. I was a maker. First thing I ever made was an RF sensor. You could, see when somebody's using a remote control, things like that. And then I kind of wandered into this thing called the ivory tower, and there's a lot of people in there I didn't like, and they kind of smelled funny. So I came back out to the maker community. But I'm actually kind of on a path. I started off in R&D. I developed things like converting DVD lasers into terahertz radiation for all sorts of new, if you guys have ever heard of T-rays. And then I was a part of a project at Intel for several years where we are creating a new type of what is called an optical interconnect, where you're using photons instead of electrons to communicate and encode information to transfer it in new processor designs. And so I kind of came into that team, and I approach electronics from molecules, whereas a lot of people kind of approach it from software and components. But I was a part of this process where I took something from being just kind of completely theoretical and fun, and let's do R&D, to actually making it through to commercialization. So they're now taking this on into a future generation of a processor. It'll be coming out in the next couple of years. So now I kind of left after getting experience going through a startup incubator and going through R&D and then commercializing that kind of stuff. And I've started my own company, and we're kind of like on the path of like iRobot. We're starting off with SBIRs and military development, and we're bringing it down to the consumer level. But as someone who started off as a maker, I've been watching this revolution go on, and I've met some great people since we moved out here. And as a materials person, I'm starting to see materials become an interest in the community. And I get a lot of crazy questions a lot. But what I want to do here is we're starting to already see some of these makers, they're manufacturing now. They're building supply chains in manufacturing, and they're getting past that first product. They're on a second product or third product. And the thing is I don't necessarily see it as going to the dark side. I think what's happening in the maker community is now we're getting to a point where some companies are going to start doing their own R&D. And you're starting to play with new stuff, and you're going to become like, starting to compete. These companies like Samsung and Intel and them, they kind of look at the maker community and they're like, whatever, but they still have a walled garden. They have these R&D programs, and some of you guys are going to build products that get really successful, and you're going to be able to channel that back. And so what I'm trying to do today is a little bit towards the future, and that is to kind of get you to start thinking about materials, because material science is coming along and really disrupting stuff. And a lot of these companies are already diving in and playing with materials. And what I want to do is I want to take this topic of wearables, because it's a really cool way to constrain makers and kind of give them new options to invent really new hardware that some of these guys that are building smartwatches or already big companies, they can't do yet. So I'm giving you access to some of these materials that are there and you may not be aware of. So in the wearables community, there's really like three things going on. There's this whole tracking of health and fitness. There's this idea of reducing cognitive overload, things like glass, the Pebble. You don't get distracted, you don't have to pull your phone out anymore. You can just ask a question and it's there. And then there's this third kind of vague area, which is this idea of personal customization and utility. This idea of incorporating your electronics into things, kind of like the Lunatic, these kind of things where it's taking conventional things we have and making new form factors and uses with them. And so all of these things are really kind of starting to invade or create their own markets, like personal wearables, $10 billion predicted by Gartner. A lot of this stuff is kind of falling into the smartphone accessory market, but we're starting to see this kind of interest in smart fabrics, and including it in apparel, and we're seeing commercials with Under Armour and the girl changing her clothes, and that's way out there. But the point is these are markets that all this stuff is kind of getting into. But the problem is with wearables and this controller is that it's not just about a seamless integration with digital tasks and behavior, like being able to get your email faster or send out a tweet. It's about like seamlessly integrating with your physicality, who you are as a person, right? And so one of the things is it's really a trade-off in that move too quickly. All right. It's really becoming this kind of trade-off between functionality and form factor, right? So electronics, we're getting access to these components because companies really made them much bigger, and now everybody can get a hold of them. But the thing is electronics by themselves are rigid and bulky. They're built with metals. They're made with PCB boards that are designed to withstand several hundred degrees in temperature when you're soldering them. And they were never designed to go through a washer, right? These electronics were never designed. They're designed to be put in a box, but they're not designed to go through a washer and then go through a dryer at high heat and get smashed around. And people are the very opposite, right? So people are soft and conformal, we're squishy, whatever. but we're also very disgusting, and we require lots of cleaning, right? So like we wash our clothes all the time, we get dirty all the time, we accumulate dirt, oil, all sorts of stuff. So, and we're forgetful. That's why like some of the Fitbits initially were designed to go through the washer. But what we really need, oh my gosh. What we really need are soft and stretchy devices. What we need are things that can be kept clean or stay clean. One of the complaints I hear a lot when I'm talking to people in the fitness and wearable space is stuff isn't really waterproof, even though they're making the claims to it. So what I'm here to do today is kind of give you guys a mindset to start working with materials, but within the context of wearables, but this same kind of structure you can take with you into any system, beyond wearables, wherever. So when you're thinking about a material, like one of the problems that I've seen from a science point of view, and obviously I think in that way, is that we've tended to like display materials as this magical thing, this thing that, ooh, look what it does. And the problem is that, yeah, you can sell that to people, but to really do something with it, you have to understand it in a way. So the way a materials science engineer kind of approaches things, and I've modified this a little bit, is whenever we want to play with a material, we try to understand it in 4 dimensions. We try to understand what it's made of, because that kind of dictates the properties it's going to have. We try to understand what those properties are, because the properties will limit how I can work with it, how I can mill it, spin coat it, do whatever I want, right? But then the other thing you have to pay attention to is its application. So there's a lot of materials that are becoming available to makers, but those materials have been, same like components. They were built because somebody needed a particular resistor, and they built 10 billion of them, right? So these materials have been scaled because they were initially designed for a very particular application. So that's not always great for you guys, because you may want to use it for something totally different than what it was originally designed for. But because you know that, you can determine whether it's worth putting on the back burner or whether it's worth just racing forward and using something with it. So let's take a look at this kind of integration of these 4 principles here. So there's been a lot of talk about conductive inks. I see a lot of stuff about conductive ink. So let's take a look at it in these 4 principles, right? Conductive inks, surprisingly, are almost their own market now. They're being primarily driven by this idea of printed electronics, but conductive inks actually make up about 1/4 of that $10 billion market. And they're primarily being used in the construction of OLEDs, touchscreens, photovoltaics, because they're lightweight, they can be made really thin. There's lots of great properties about them, but the ones that have been the most successful are the metallic-based systems. And they've primarily been silver, which is really expensive and has led to the reason why we're trying to develop more copper-based inks, and these are now available. But the thing is they're metals, but they have a larger structure. You're working with them in the form of a flake or a nanoparticle. But the other thing is, because it's an ink, you have binding agents and you have solvents you have to think about now. So it's not just a metal in terms of its resistivity you have to be familiar with, which is what most people are used to with circuit boards. You have to think about the sheet resistance. You have to think about the boiling point, because the chemical properties, these inks, some come in water and some come in organic solvent. And that's a huge difference in California. You're actually supposed to build all your printed electronics from water-based systems. If you're not, you have to spend money recycling the organic solvent, which can be really costly when you're trying to set up a manufacturing line, right? And so it's being familiar with these properties. It's a new way of playing with circuits. So it's being familiar with the structures, being familiar with the properties, but what's been driving it is the manufacturing. You can spin coat this stuff. You can use flexographic printing. You can silk screen it. And the thing is we're talking about the guys that are making T-shirts today will be making circuits tomorrow. Who knows when we'll see like a Zazzle for electronics. That's becoming a possibility, right? And so right now what you're seeing it be used for is PCBs, resistors, RFID antennas. It's being used as heating elements for anybody who has like the Columbia boots that can heat up when you're out in the snow or whatever. But what's great is you can do circuit design on the fly. You can design a circuit, test it. If it doesn't work, if you have an inkjet system, you can just print it right out, or you can silk screen it. And so the next evolution of this is how you connect stuff to it. Well, right now we're kind of limited to things like copper tape. But these same companies that are working on the inks and now have got it there are working on conductive adhesives now, new alternatives to solder. And so what I want to make sure I do here is I tell you where you can get this stuff. So go play with bare conductive if you want to play with conductive inks at a cheap price and learn how to use it. But what you really need to pay attention to, and this is the thing I see in the make community when they ask me about this stuff, is pay attention to the key property here. It's a conductive ink. You have to understand that it's about the ohms per square in terms of sheet resistance. So bare conductive is great, and it's cheap to play with. It's based on carbon black. There are other carbon systems coming that will be much more conductive, like graphene and carbon nanotubes, but they're still a little too pricey for this stuff. So you can play around here in this space to kind of get a feel for inks, but when you're ready to go pro, or you're onto your second or your third product, you can start talking to guys like Novacentrics. These guys have got it. They believe in you guys. They're all about the make. They have gone through the trouble of making silkscreen kits to start working with. They have YouTube videos to show you how to do this stuff. They have been making cartridges that drop into Epson printers for you guys to work with. They show you how to clean the cartridges and everything. So there's a little bit more complication to it. So keep that in mind. That I can talk to you if you want to know more about it. Let me know afterwards. Next thing is polysiloxanes. Who's heard of MC10? Raise your hand if you've heard of MC10. MC10 is a company developing stretchable electronics. This is a key component to what they're doing. Polysiloxanes are going to be the way every type of stretchable electronic is built, or this is like the first generation is going to be built on. And what's great about polysiloxanes is they're highly derivatized. So people are using them to make stretchable substrates. They're using them to make waterproof enclosures. These things are biocompatible. They're being used in medical implants already. You can tune by changing the properties in there. You can actually tune it to be really stretchable. You can make it rigid. This is a tunable system. It's its own market. We've been using siloxane stuff for years. You can find it in gaskets. You can find it in sealants and construction. It's in the nacho cheese at the movie theater. The thing about it is they're made from silicon and organic compounds, right? And so they're elastomeric, which means rather than a polymer is a linear chain with a single molecule repeated over time, elastomers are star shapes. They kind of branch out into other ones, and they branch out. That's where they get their elasticity from. So play around with this stuff, and I'm going to tell you where you can get it. But it's a key component to stretchable electronics and kind of this conformal idea of stretchy devices. And you can manufacture it casting, reactive injection molding. It can be cured thermally and photochemically. And I'll hopefully put these slides up, so I know I have to blaze through this stuff for you guys. This is the stuff. You guys, how many of you read about the stretchable battery a couple weeks ago? Anybody? Stretchable battery. This is what people are using right here. This is called PDMS. It means polydimethylsiloxane. It is the stretchable kind of prototype material to build stretchable electronics on. You read about it in Gizmodo and all these things. This stuff you can get on eBay and Amazon for 40 to 60 bucks for about a quart. I also recommend when you want to get more specific, people who are ready to go pro and want to have more design formulas to have different properties, you can go through these guys to find more specific monomers to do different things or have different properties if you want. Generally run you starting over like about 100 bucks for 500 mils to prototype with. Gets cheaper if you go huge. My team, we put out an Instructable like 2 years ago to use this stuff. So you can make really quick testing for waterproof and waterproof your electronics. You can make form factors. It's not like epoxy. Epoxy is permanent. Once you've cross-linked it, all of your devices, all your stuff is trapped in there. You can't get it back out. This stuff, you can quick test it, test its form factor. If you don't like it, you can cut it off and keep all your electronics without having to rebuild everything. So if you want to learn how to play with it, I go through different ways to cure the elasticity if you want, play around with changing stretchability, making it rough. We go through all that and teach you how to do it. I have some with me if you want to come check it out, all the different formulations. Lastly, everybody's heard about super hydrophobic coatings probably, right? Everybody saw the EverDry, the Ultra EverDry video. You guys watch TED, all that stuff. This is an alternative to basically waterproofing. It's this idea of just keeping water completely off the surface. It's getting, the biggest driver for this stuff is actually corrosion inhibitors. Out in industry, we're trying to, we have lots of infrastructure that's rusting and falling apart because of water gets in the cracks and everything else. But by these kind of coatings are actually helping us kind of keep water from getting in there. So that's what's driving this. But what's happening now, you guys have seen these demonstrations where people are dropping phones in water and it's like 30 minutes and the phone's still playing. It's because they're using these systems. And so it allows you to kind of encapsulate or kind of keep water from getting into something without permanently encapsulating it like an epoxy. The thing is right now it's mostly coating based, so it's not going to be completely durable, but there are people working on ways to literally, you have your product made, you had it manufactured, it's come back. They are going to be able to throw it into like a lasing system and literally carve the microstructure. So the way some of these work is a microstructure, really, really small structure, functions a lot like those nail beds you always saw in the 80s, like people laid on them with the bed. It's like that, but at a microstructure level, and it's keeping the water pushed off. That's what's giving it. And so the most important thing to think about is called the contact angle. Listen to me, contact angle. If it doesn't have a contact angle over 150, it's not super hydrophobic. Some of you are thinking, oh, Rain-X. No, Rain-X actually only gives you a contact angle of 110 degrees, okay? This is going to be something that probably becomes much more common because it repels water, oil, keeps proteins and bacterium from accumulating on the surface of electronics or wearables, what makes us gross, right? So you can play with this. You can get the EverDry, you've seen in the video. It does leave kind of a cakey thing on there, but it just allows you to kind of test this idea of super hydrophobic surface. Is it for you? You can get this stuff on Amazon Supply for about 170 bucks. It's a 2-coat system. You put one on, it uses like spray coating, like what you would use for painting your house. You can put this on, and it forms the microstructure. But like I said, go watch the video. If you haven't seen it, you'll lose your mind. When you're ready to go pro, like if you've got something built, you can talk to these guys. They specialize in taking your finished device. They put it inside of a deposition chamber. And what they do is they alter the surface, not the electronics, nothing else about it. What they do is they alter the surface so they can attach particular molecules to it to keep water and oil from accumulating on your devices. These are the guys you want to talk to if you've got a finished product and you just want to make it a feature of your product, or if it's a wearable and you can say it doesn't smell, things like that, or doesn't get wet. These guys are great. They're getting huge money for they're the liquid glides. They're the one that put it on the ketchup bottle. Did everybody see that video? That's them. But like I said, so fun, have fun with it. The other side is when you're ready to go pro. You're talking about second, third generation. You're ready to spend some serious money on accumulating or building this stuff into your technologies. That's it. Here's some other cool sites about materials to help you kind of keep post on industry. You can't really buy chemicals from Sigma. They're for professional guys. But you can get lots of really great chemical data, property data. They give all sorts of information about solvents, what they'll dissolve in, things like that. But that's it.